Okay, so in example 8, we're going the other direction. You can tell we're starting with polar because you see r and theta, or maybe at least theta show up. And so we're going to use the same relationships we've worked with to convert back. Now, again, there's sometimes more than one way to do these problems. In this problem here, I see r and I see 2 cosine theta. Now, keep in mind, I'm trying to convert to x and y. So there's really, in this case, 2 approaches here. I almost have an r cosine theta, I'm just missing an r. Or you can try to think of it as I have an r on the left, so maybe if I converted that to r squared. Or in our particular case, these could actually kind of coincide, right? So basically what we're going to do is we're going to multiply both sides by r. Now when we do this, we get r squared on the left, and then we create that r cosine theta on the right. This allows me, anywhere I have like a trig function or an r, to replace it with something in terms of x and y. Because on the left, I know that r squared is x squared plus y squared, and on the right, I now have an r with a cosine theta, which is what I was looking for, to convert that to an x. And then we can't really, solving for y here isn't what we normally do actually when it's squared like this. Oh, you know what we do here. If you think way back to your conics, way back. What we're actually going to do here is try to complete the square. So to complete the square, I'm trying to think of something x minus half of this term here would be x minus 1 squared, which means that number squared is what I need to add in here, which means I also need to add it in here. Okay, now this is looking more like it. And if we think about this and what type of shape it is, we have now converted it to the rectangular form of a circle, right? That's just been shifted. The center has been shifted 1 to the right of the origin and has a radius of 1. Okay, so in part B, what looks kind of funny is there's no r at all, right? So we're going to actually avoid any of the r converting and focus on the fact that we have an angle here. And if you think back, if I see an angle, I'm thinking about taking the tangent of that angle to convert it. So we're actually going to take tangent of theta and tangent of the other side. Because if we do it to one side, we have to do it to the other side. So then tangent of theta, that's just y over x. Tangent of 3 pi over 4, let me think about that. That's going to be quadrant 2. So they have different signs, so it should be negative 1. So then we get y equals negative 1x, or just negative x. That's just a good old straight line. All right, and then the last one, r equals cosecant theta. We don't have anything with cosecant or secant, so I would go ahead and convert that in terms of sine and cosine. So that's going to be 1 over sine theta. We're going to multiply that over, which actually, wow, that sign looks a little weird. Come on, Miss Wright. Okay. That should make you pretty happy because we have something that we can convert our sine theta to, and that's simply y. Another straight line. Awesome. That'll conclude our converting questions.